I'm going to learn about a property called the square root property. It's used for solving certain types of quadratic equations. Now, a quadratic equation, remember that means an equation of the form ax squared plus bx plus c equal to 0, where, of course, a doesn't equal 0, or it wouldn't be quadratic. This term wouldn't be here. And we also want a, b, and c to be elements of the real numbers. Now, the first thing we need to understand about the square root property is that every positive real number has two square roots. You're used to seeing the principal square root symbol. You're used to seeing, for example, that the square root of 25 equals 5. This tends to make people, leads them to believe that a number only has one square root. But if you write an equation in the form x squared equals 25 instead of just writing square root of 25, then what you're asking is, what do I square to get 25 for an answer? Now, of course, the first and most obvious is 5. But it's not the only thing. If you think about it, negative 5 would have to be an answer as well, simply because 5 squared gives you 25, but negative 5 squared will also give you 25 because squaring gets rid of that negative sign. So the first thing I guess to remember as we get ready to use the square root property is that you have to have the plus as in the positive result and the minus as in the negative result. Now the square root property actually says that if x squared is equal to a, then x is equal to the square root of a, or x is equal to the opposite of the square root of a. Now we can often abbreviate this as x equal plus and minus square root of a, but that is just to emphasize the fact that we're going to have two roots coming out every time we use this property. Let's look at an example of how this property is used to solve an equation. Let's say that we had a square equaling 49. Square root property is basically saying to get this square off of the variable, you can take the square root of both sides of the equation. Now, as you take the square root, what happens is the square root cancels the square and the variable comes out. And this property says, remember the plus or minus. So plus and minus 7 is going to be the two solutions to this problem. Now, to use this property, the variable, or the term that contains the variable, has to be isolated before you can take the square root. Perfect example, if I had a 9x squared plus 5 equaling 20, the x squared isn't by itself yet. It isn't isolated, so I'll have to do that first. I will subtract 5 from both sides, and I'll get that 9x squared equals 15. Then dividing by 9, I get that x squared equals 15 ninths, which is x squared equaling. I'm just going to go ahead and take the square root of both sides. Square root of 15 over 9, and don't forget the plus or minus. So x turns out to be plus and minus square root of 15 over 3. Now, if you're wondering where did that 3 come from, I can't take the square root of 15, so I'll leave it under the square root. But I can take the square root of 9, so that's where the 3 comes in, as I'll just go ahead and I'll take that square root, and I've done all the simplification that I have to do at that point. Now let's look at another example like that one. Let's look at 16x squared minus 17 equaling 56. I will first add the 17 to both sides, and I get that 16x squared is going to equal to a 73. Next, I will divide by 16 on both sides, and I get that x squared equals 73/16. Now we will use the property. Taking the square root of both sides, I get x equaling both plus and minus square root of 73 over 4. And again, the 4 is the result of taking the square root of this 16. And there we have our answer. Now we're going to move next to a problem that involves some grouping symbols. If I had, for example, a d plus 6 quantity square equaling 20, because of these grouping symbols, I have to remove the square before I can do anything about the 6. So like before, I'll take the square root of both sides. I'm going to get that d plus 6 equals the positive and negative square root of 20. Now I'm going to go ahead and try and simplify that square root of 20 a little bit. I'm going to have that d plus 6 equals plus and minus square root of, the best way to break apart the 20 is a 4 times 5. So d plus 6 equals plus and minus 2 square roots of 5 when you take the square root of the 4. Last thing to do is to get the d by itself. Now this plus and minus was a positive and a negative, but when this negative 6 comes over, you can look at it as a, oops, put that one in the wrong place. You can look at that as an add and subtract. So those are your two solutions in an exact form. But if you want to know what they actually equal, you have to go to the calculator, where we can type in negative 6 plus 2 square roots of 5, and you find that one of your solutions is approximately negative 1.5, and the other one, when you approximate it on the calculator, is a negative 10.5 approximately. So there you have an exact solution and the two approximations of that exact solution. Alright, let's look at another example of that type. Let's say that we had a 2x plus 3 quantity squared equaling 18. Using the square root property first, I get that 2x plus 3 is equal to plus and minus square root of 18. And again, I want to simplify this. 2x plus 3 equals plus and minus square root of 9 times 2. So 2x plus 3 equals plus and minus 3 square roots of 2, because I can take the square root of 9, and I do, and it's the 3. Moving the 3 over, it becomes a negative 3. And one more step on this one that I didn't have before. I will divide off that 2, and x will equal negative 3 plus and minus 3 square roots of 2 over 2. And like before, those are your two exact solutions. To see what they are roughly, approximately, we'll go to the calculator. I'll take negative 3 plus 3 square roots of 2. And I have to hit enter right now because you have to force the calculator to figure the numerator first. Once the numerator is finished, you can come back and say divided by 2 afterwards, and there's one of your answers. The other solution is negative 3 minus 3 square roots of 2. Again, hitting enter to force it to figure that numerator Then you can divide by 2 afterwards, and there's your second solution. So positive 0.6 and negative 3.6 are going to be the two solutions to this in an approximated form, and here they are in their exact form.